In section 4 of the textbook, chapter 3, we look at the measures of dispersion. Remember, in section 3, we looked at the measures of location. But now we are looking at how dispersed the data may be. And we're going to look at range, variance, and standard deviation. The range, for example, the number of cappuccinos sold at the Starbucks location in the Orange County Airport between 4 and 7 p.m. for a sample of 5 days last year were 20, 40, 50, 60, and 80. Determine the range for the number of cappuccinos sold. Well, the range is just taking the maximum value and subtract the minimum value. In this case, 80 minus 20. So the range would be 60. The variance and the standard deviation. The variance is the average of the square deviations from the mean. And the standard deviation is just the square root of the variance. The variance and standard deviations are non-negative and are zero only if all observations are the same. For populations whose values are near the mean, the variance and standard deviation will be small. And for populations whose values are dispersed from the mean, the population variance and standard deviation will be large. The variance overcomes a weakness of the range by using all the values in the population. Remember, the range uses only 2 values. The population variance is equal to sigma squared. The Greek letter sigma, lowercase, is a sign for the variance. Is equal to the summation of x minus mu. Mu is the mean of the population, the average, squared, divided by n, where n is the number of observations in the population, or the number of numbers. So the steps to calculate the variance are, you first calculate the mean. The second step is you calculate the difference, notice the parenthesis here, between each observation and the mean. And you square that difference, and then you add the differences. In other words, we're going from right to left here. And then divide the sum of the square differences by the number of items in the population. Let's look at this example. The number of traffic citations issued during the last 12 months in Beaufort County, South Carolina, is reported below. So you have 12 months of traffic citations. What is a population variance? Well, you find the mean first. You add all these numbers divided by 12. That gives us 29. Second step, find the difference between each observation and the mean of 29 and square that difference. You can see here on the right hand side here. 19 minus 29 equals minus 10. 17 minus 29 equals minus 12. 22 minus 29 equals minus 7. Then you square, in step 3 here, you square these differences. Minus 10 squared is 100, minus 12 squared is 144, minus 7 squared, 49, etc. Notice how these numbers, since they are being squared, are the result of squaring a number here on the right hand side, so all of them are positive. Then the final step is you add them up, all these differences squared. And that will be your numerator in the formula. Sigma squared is equal to the summation of x minus mu squared, that's 1488, divided by the number of observations, 12, equals to 124. And the population standard deviation will be equal to the square root of this number, which will be about 11 point something, 11.1, 11.2. You also can calculate the sample variance. Sample variance, we indicate with a letter S squared. Instead of sigma squared, remember, Greek letters are assigned for the population statistics or population parameters. And the sample statistics, for the sample statistics, we use normal letters or Roman letters. S squared is equal to, again, notice the summation of x minus the average, in this case, the average of the sample, squared divided by the sample size minus 1. Little n minus 1. Little n indicates the sample size. For example, the hourly wages for a sample of part-time, notice that it says a sample, of part-time employees at Home Depot are 12, 20, 16, 18, and 19. Well, how do we calculate the sample variance? First, we need to calculate the mean. Add these numbers, divided by 5, 1, 2, 3, 4, 5, that gives us 17. So from each number, 12, you subtract 17. You get minus 5, 12, 20 minus 17, 3, 16 minus 17, minus 1, 18 minus 17, 1, 19 minus 17, 2. And square each difference, 25, 9, 1, 1, and 4. And the summation of that will be 40, which is the numerator here. And divided by 5 minus 1, 40 divided by 4, that gives us 10. So 10 is the sample variance. And the sample standard deviation will be the square root of that, which will be about 3.33. What is the sample standard deviation? Well, just the square root of S squared. In this case, the square root of 10. And that is the end of this section.